This is section 4.3, and today we're talking about right triangle trigonometry. So the first objective that we're going to talk about today is how to use right triangles to evaluate the trigonometric functions. Now, this is our basic SOHCAHTOA that we've learned in geometry. Remember, it means that sine is the opposite side divided by the hypotenuse. Cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. Now, that means that our reciprocal function, for example, cosecant, the reciprocal of sine, is going to be our hypotenuse over our opposite side. Secant, the reciprocal of cosine, would be the hypotenuse over the adjacent. And finally, cotangent would be the adjacent over the opposite side. And let's just fix that to say cotangent. Now, if you need a reminder on which is the opposite, the adjacent, and the hypotenuse, remember that given your angle, across from your angle is always the opposite side. So when you go opposite your angle, you get the opposite side. Opposite the 90 degree is always the hypotenuse, and then the last one will be your adjacent side. So how can we use this to help us? Here's our example. We want to find the values of each of these 6 trig functions if b is 4 and c is 2 root 5 in that given triangle. Now the first thing we're going to have to do is use the Pythagorean theorem to find our missing side. So a squared plus 4 squared equals 2 root 5 squared. A squared plus 16 equals, now this is going to become 4 times 5, which is 20. And we'll subtract 16 from both sides. So a squared is 4, and when we square both sides, a is going to be 2. So now we have our missing side of our right triangle. A is 2. Now that we know that, we can go through and find all the 6 trig functions just using SOHCAHTOA and their reciprocals. So sine of theta is going to be the opposite over the hypotenuse, so it's going to be 2 over 2 root 5. The 2's will cancel out, and we'll have to rationalize the denominator by multiplying by root 5 over root 5. So it looks like our answer becomes root 5 over 5. In terms of cosine, cosine is adjacent over hypotenuse, so we get 4 over 2 root 5. Once again, we'll cancel 4 divided by 2, and we'll get 2 over root 5. And then we'll rationalize the denominator by multiplying by root 5 over root 5. And it looks like the answer is 2 root 5 over 5. Tangent is opposite over adjacent, so we get 2 over 4, which simplifies to 1/2. Now, we can go ahead and use the right triangle to continue to find the reciprocals, or we can use the answers from above and flip those over. Cosecant, for example, the reciprocal of sine, I'm going to flip over the unrationalized version of this answer and get root 5 over 1, or root 5. Now, you could also have solved this by saying, cosecant is going to be, instead of opposite over hypotenuse, it's going to be hypotenuse over the opposite side, and you can see that that's another way to get the root 5 answer. In terms of secant, once again, I'm going to go ahead and just take the reciprocal of cosine, but I'm going to use the answer before I rationalized and get root 5 over 2. You could also do the hypotenuse over the adjacent side, so we'd have 2 root 5 over 4, and 2/4 is 1/2, and you can see either way you get the same answer. And then the same process for tangent and for cotangent, and we would get 2 over 1, which is 2. Now, if you used the idea of the right triangle for cotangent, we would do adjacent over opposite, 4 over 2, which also simplifies to 2. So you can see that once you get your right triangle filled in, you can use SOHCAHTOA and the reciprocals to get all of the values of the trig functions. Alright, here's your multiple choice question. Given this triangle, I want you to find the cosine of theta. And make sure you answer this one into your Google form. Then we'll go on to the next slide. Now, this next slide is using the idea of cofunctions of complements. First of all, I would not write down these 6 formulas. Wait until you've seen the whole slide, and then I would decide what to write down, because I don't think that these necessarily explain the cofunction identities very well. So let's go ahead and get started. The first thing is to remember what the complement means, and complements, remember, are 2 angles that add up to 90 degrees. So we're talking about angles that add up to 90 degrees. Let's look at the picture of a right triangle for a minute. I'm going to go ahead and fill in 2 of the angles, 70 degrees and 20 degrees. Now let's take a look at a few things. Let's look first at the sine of 20 degrees. Now sine is going to be opposite over hypotenuse, and I don't know what these lengths are. We'll just call them A, B, and C. Now if I go from 20 degrees and I find the sine, it's going to be A over C. Let's switch it to cosine now, but let's also switch our angle to be 70 degrees. The cosine of 70 degrees, now cosine is adjacent over hypotenuse, and we've switched angles. And once again, we get A over C. Now notice that the sine of 20 and the cosine of 70 resulted in the same answer. Cosine and sine are what we call cofunctions. And cofunctions of complements are equal. Notice they equal the same thing. So sine and cosine are cofunctions. 20 and 70 are complements, and we can see those 2 are the same thing. Now I could also switch it the other way around, and I could say that the sine of 70 is equal to the cosine of 20 degrees. So it could be the other way around. As long as the angles are complements and the trig functions are cofunctions, then that means they're equal. So here, now let's look and see what our pairs of cofunctions are. The first ones are sine and cosine. We also have tangent and cotangent, and finally cosecant and secant. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. Let's look now at how this is used in an example. We want to find a cofunction with the same value as the sine of 72. First off, sine's cofunction is cosine. Now the other thing I need is its complement. So we're going to take 90 degrees and subtract 72 from it, and we get 18 degrees. So that means that the cosine of 18 degrees has the same value as the sine of 72 degrees. Now for our next example, it's cosecant of pi over 3. Now cosecant, first of all, its cofunction is secant. Except now we have pi over 3. We're dealing in radians. That's okay though, because we know that 90 degrees is the same as pi over 2. So we'll just use pi over 2 and subtract pi over 3 from it. We need to use some common denominators here, so I'm going to change these both into sixths. Pi over 2 is 3/6, and pi over 3 is 2/6. And so we get an answer of 1/6, or pi over 6. That tells me that the secant of pi over 6 is the same as the cosecant of pi over 3. Our final objective for this video is using right triangle trigonometry to solve applied problems. Now, the one thing that's important to know when we're dealing with these word problems in right triangles is some vocabulary. So, if a person is standing and they start looking straight ahead at the horizontal, and then they look up towards the sky. That's what we call the angle of elevation. So they start looking horizontally, and then they look up. That angle in there would be the angle of elevation. If I go the other way and I look straight ahead and then I look down, that's what we call the angle of depression. So just knowing that those two words is going to be important to us. Notice we always start by looking straight ahead, then we look up or down. All right, here's our example. We have an irregular blue-shaped pond shown in the picture. The distance across the pond is unknown. To find the distance, a surveyor took the measurements shown in the picture, and we want to know what is the distance across the pond. So in terms of our angle, we're trying to find the opposite side, and we're given the adjacent side. So hopefully you're thinking we should use tangent. So we'll say the tangent of that angle is equal to our opposite A over 1,200 yards. And now we're trying to solve for A, so we're going to multiply both sides by 1,200. When I do that, 1,200 times the tangent of 24 degrees will become my answer. And I'm going to punch this into my calculator, making sure I'm in degree mode, and I get 534.27 yards. Here's your free response question. You're going to find the height of the tree if the shadow is 50 feet when the sun is at a 30-degree angle. Make sure you put this into your Google form, and this will be the end of the video.